useReducer is a hook in React that makes handling complex state in functional components a little bit easier and manageable. And in this video, we're going to go over how to use it and when you should use it. This is the fourth video in my React Hook series, so make sure you check out the other videos first. If you found this video helpful, don't forget to like and subscribe. Now let's jump in. useReducer is one of the hooks I was a little resistant to at first. I found myself using useState for most things, and you know what? A lot of the time useState will be perfect. But when you get used to using useReducer, it can make working with complex state really easy. It can also give you performance boost if you find yourself triggering changes based on other state changes. That might make more sense in a few minutes, so bear with me on that one. And it's actually recommended by React to use useReducer when you have complex state. And I'll show you that here in the docs. So in the useReducer section, we can see it is usually preferable to useState when you have complex state logic that involves multiple subvalues or when the next state depends on the previous one. So even the React team themselves are saying this is the way you should probably be managing complex state. And these tools are there for a reason. So let's have a little look at their sample while we're here as well, so we know what exactly that useReducer accepts and does. So useReducer is a function just like useState, and it expects a couple of arguments. We have a reducer, which is a function that we pass to it, a reducer function. And if you're familiar with Redux or things like that, this is the same as that. We get a reducer that we pass to it and an initial argument. An initial argument is very like we have in useState, where it can be a function to lazy load it or just a straight up argument if you want to just put in a default value. So our initial argument will be state. And then, just like useState, we get a second parameter, which is actually our function to update the state. The difference here is the dispatch function works a little bit different than the setters that we'd be used to in useState. So if we look at the code sample here, we see here that we have a reducer set up here, and it's expecting a state and an action. Okay, but when we use the dispatch function, we actually only have to pass it our action, and it automatically applies the state to our reducer for us. So here we're just saying an action, which is an object with the type of decrement, and when we click it, it will go into here. We have a switch case, and we're looking for the action.type of decrement, and then it will return a new state, which is the state.count -1. So then wherever we refer to state, it will update. So let's refactor my code over here, or talk about first how this code is set up and why it's probably a good idea to use the useReducer hook. So in my to-do app here, it's working away. We can mark things as done or not done. We can delete things. We can add things. And yeah, cool. So it's nothing too crazy here. And when we look at these things, most of it is pretty okay. So first off, we're saying with our to-dos, we set some initial state or initial values, which is just these values up here. And that's just so when we load the app, we actually have some values and don't have to add in some values every time we refresh the app. We have the setter. Then we have the next to-do ID and the set next to-do ID. And that's so every time we're creating, actually this can be 3. Every time we're creating a new to-do, we need to increment the ID so that we don't have the same ID ever. So when we delete and add items, we have unique keys always. Then we have the new to-do label and set new to-do label, which is going to actually basically keep track of what's in our input here. In our use effect here, we are tracking the to-dos. So anytime the to-dos change, we are going to update the next to-do ID by adding 1 to it. Okay, so already here, this is kind of one of those things where it says in the docs, when the next state depends on the previous one. So this is kind of one of those scenarios already. So there's a small red flag straight away. In the mark to-dos is done. It's pretty straightforward. We're just setting to-dos and mapping out an array, so it's not too complex there, so that's fine. The same with the remove to-do, but when we get down to the add new to-do, we have a few different things going on. So we're adding a new to-do, setting to-dos to spread the to-dos out, and then we're adding the next to-do ID. We're grabbing the new to-do label, and we are marking that as false by default, and then we're setting the new to-do label as empty. So this kind of area here where we're doing a lot of managing the state and things like that, we are actually, there's just better ways of managing it. So let's jump in and try to start refactoring this. The first thing we're going to do is import useReducer. And let's set that up at the top because we're going to eventually delete some of the other stuff that we have in here. And we're going to say const state, which will be our state that we'll refer to, and we'll have our dispatch function, and that will be returned, those items will be returned from useReducer, and we're going to pass it this reducer function in just a second, and we'll take the initial value of the initial state, just like we have in our to-dos down here. Awesome. So now that we have this set up, I think let's start by working on setting up a very basic reducer function here. So let's go outside here and create a function called toDoReducer, and you can call this whatever you like. There's no naming conventions here, and this is expecting a state and an action. And inside this, it's kind of a convention that we say give this a switch that will look for the action, and by convention it's going to look for a thing called action.type. As we can kind of see back in the docs, they're using, even though it's a single value, they're using a type inside an object here, and that's just because sometimes we might want to pass in more than just like a string along with that. We might want to pass along some values. So by convention, we're just going to say action.type, but you could call this whatever you want. It's not necessary to call a type. And this will then take a few different, this is where we're going to start us just working through the different actions we can take. So we'll refactor the easy ones first. I'm just going to go give this a default of return state, just so that it doesn't scream at me for not having a default statement, because that's the way the linter is set up. And I'm going to just instantly replace this in here. So this is our toDoReducer setup. So let's first look at the mark to do as done and try and refactor that first. So the mark to do as done is just filtering by ID. So let's create, and I like to make constants for the action types so that I make sure I don't get typos. So I'm going to make a little array here because I know I'm going to have a few of these set up. And we'll say mark done equals, I'm going to copy this, equals mark done. And that's just so I can refer to the variable around the place, and I know I'm getting it spelled right every time. So we'll say in here, we'll add a new case where the action is mark done. And inside here, we're going to return done. We're going to return the state.map, and we're going to take the item, caps on by accident, and we're going to take the item, and inside here, if the action dot, and here's what we're going to do. We're going to need something else here, because if we need to check for stuff, we're going to need probably an ID to check for. So we'll say if action.id, so we'll pass this in where we're passing in the same type. We can say if action ID equals item.id, we can return and spread out the item, but the done is going to be equal not item.done. Else we're going to just return the item. Cool. Excellent. Now, because it's the first one, let's wire this up so we can see this in action. So the mark to do is done here. So let's see where we're looking for that in the code. And we can say, okay, we don't even need this checked anymore. We're not using that. But we are sending an ID. So that's where we're going to keep sending that. So instead of calling this, we're going to actually use the dispatch function here. And the dispatch, we're going to send an action. And just by convention, we're going to send it an object. And the ID is going to be the to-do ID. And the payload, or sorry, the type is going to be mark done. Cool. And so we can have a look and see there's some little problem here. Okay, yeah. So the reason this is because now, instead of mapping all our to-dos, I'm actually mapping from our state here. So I'm going to first have to just make sure we'll say state.map here so that we have that. And then we're actually mapping from that. And now we can see down here is mark to do as done is assigned a value but never used. So we can just delete that now. Cool. So the next one we'll do is remove to do. Okay, so let's make a new case up here. So as you can see, like, this is really nice already, because we can like think about what the user is trying to achieve rather than, and which makes it a lot more declarative, and we can extract the logic that does those things somewhere else. So outside the function here, we have our little reducer that handles all the changes. So let's add a case here of remove to do, and we're going to have to, I'm going to set this up the same way as I set before, and then we are going to just give that the same string here. So remove to do, so now we have our case there, and in our remove to do we're going to return state dot filter, because we're going to filter out the item we don't want. And we can say, very similar to the done, we're going to want probably an ID pass in here as well as the action type. So we can say item, and we will return if the action dot ID is not equal to item.id. Cool. So I'm going to save that. I'm going to remove this here. That's kind of out of the way. And we can have a look for the remove to do. And we are going to do something very similar here. So we're going to dispatch. I'm going to copy this one because I'm lazy. Put it in here. And we can say remove to do. And let's have a look. Cool. So now we have one function doing two of those things. So we're dispatching the mark done and remove to do. So let's move on to the add to do now. And for the add to do, we are going to take one more parameter because we're going to actually need the text as well. So we can then create the new case here, as I've been, well, maybe not after the default. We can add the case up above. So, not enough coffee today. New add to do. And the same as before, we're going to add it up here. Delete this out of the way. Cool. That's not throwing us an error. And then we're going to return an array because that's what we had initially. And inside that array, we're going to first spread the state. And then we are going to construct a new object to add on to the end. And what we're going to do here is we're going to say id equals action.id, like we've been passing around the ID so far. So we're going to figure out how to pass that one in. And then we're going to say label is action dot label, we'll call it. And then we will set the done to be false by default, because when we have a new to do, we obviously don't want it to be done just yet. So let's grab the pieces here. Oh, we don't need this anymore. It's gone, should have been gone already. And let's add add new to do is right here. So instead, kind of like before, I'm going to just copy and paste this whole thing in. Except I'm going to say add to do. Then we are going to say the ID is now going to be our next to do ID. And then we are going to say the text is going to be our new to do label, or our label, sorry, we call that label back up on the top, so that'll go and throw an error if I didn't do that. So let's just see if this works, and then we'll do a little bit more cleaning. Sweet. So add new to do is no longer used, so we can get rid of that now as well. But as you can see, it's not clearing anymore. So maybe we'll want to say break this out just to make it easier to read. And after, we can set the new to do label to be an empty string. And let's just save that. And so if we add now, yeah, cool, it's an empty string. Okay, so let's delete the add new to do because we have all that covered now. Now, the other thing is, so we have a couple of options here. If we wanted to kind of track the field value. We could actually, if we wanted to do this all in a reducer, we could then kind of change the initial structure of this to have a few more things. So let's actually do a couple of things. So let's say we want to track our label inside our inside our reducer as well. So let's add a new case of label or update label, and then we are going to have to do a little bit of a refactor here, because our state is no longer going to be this shape that we were using so far. So we can just say update label, boom, and when we update the label, we're going to now have, I think, an initial state of an object. Okay, so we're going to change this initial state now to be an object, and to-dos is going to be an array inside there, and then we can have the label as empty. Okay, and then we'll put that there. And if we go, we can actually just from the state say const to-dos and label equals state to destructure them off it. We're no longer using this, so we're going to get rid of that. And I'm going to actually comment out this for a second, because we don't want that either right now. State.map is not a function anymore because it's now an object, so we're going back to our original to-dos.map. Cool. And okay, so we're not looking after the state.map, so it's actually going to be a little bit of refactoring here to get this to work as expected. So what we're going to do is get everything else working in a second, but let's look after this. We can say update label, and we will return state, and boom, that's all our state, and our label can be action dot value. I'm going to call this, so the value that we'll send in with the dispatcher there. So the state structure here is no longer going to be the same, so we're going to say the exact same here. So we're going to change this to this. So we'll say const to-dos equals state, and we're going to spread out the state, and inside the state we're going to spread out the to-dos into an array, no longer an object. Oop, forgetting how to type here. I've done something wrong here. Let's have a look to see where we can fix it. So we're spreading out to to-dos, and then our to-dos are going to equal spread out the rest of the to-dos, and then we're going to add on a to-do here. So we have a new set of to-dos, and everything else is the same there. And then we're going to kind of follow the same logic in the mark done as well. So because we have a slightly different structure. We're going to say we're going to return an object. So let me just pull this down here. And the same, we're going to destructure off the to-dos, just so we can spread them out easier inside. Return state, so we have everything the same, but then our to-dos, and we're updating to-dos equals, and that's going to be our to-dos.map. So we're going to copy and paste this then. Then we can remove this. So mark done. Is this because, okay, just because we didn't, so const. Oh, actually, yeah, so this is because we've declared this in here. We shouldn't. So I'm going to pull this back out so we can destructure off the to-dos whenever we need it, because we'll need that in a lot of these. So it's easier to pull it out off there. Linters are great for telling us that, and then we can say the same. So to-dos.map, and then remove to-dos is going to be similar again. We're going to return to-dos filter. Let's refresh this. So it should be back working now. Cool. Okay. So now we should be able to update the label, but we had to, like, as you can see, just to add that piece of state. But now, anytime we have to change something again, we're in an object, so it should be a lot easier. So I just wanted to show you like how we kind of go through these. Now you could have left the label as it was so you could change it, but I think it was better that way. So now we need to remove where we're using the to-do label. So we'll say update label is going to be dispatched now for any time we on change. So instead, we're going to use our dispatcher here. I'm just going to copy this. And we'll dispatch this into update label. And we'll say label is target dot value. And then the value will have to be state dot, oh well, actually we already destructured that, so we can say label. And now, as you can see, we're actually able to update through the reducer. Nice. And now if we add it, the other function doesn't actually do anything anymore. So we can delete that. And instead of calling another action, when we say our add to do, we can just go back up to our state here and we can say label is now empty. Awesome. So we don't need another setter. So now if we add this, it clears it. Perfect. So what we're missing now is the, actually we can say state dot label. This should be doing it because we're getting a little bit bugged there. No, let's have a quick look. And we can say is action.label is going to be, so our action.label now is expecting a different kind of label. So that's where I was going wrong there. So if we go to our to do label is no longer new to do label, it's actually just label, which because we're using the same thing, we can shorthand this, and now we should actually have it back running. No, let's have a quick look and try to debug this. The pleasures of debugging live. So I'm going to console log out my state to make sure we have everything as expected. Label. Okay, so of course. Such is life. You see, little bugs throwing me a little bit, but we got there eventually. So here we go. And now we can see that we have our labels updating as expected. So we should be able to add things now. Perfect. Now we're getting the unique keys error. Okay. Now I have a cooler way to solve this unique keys error. So usually when we are, setting a next to do ID, and let's actually remove all these, but this is the only value we care about now. Usually when we have a value that we don't want to really cause a re-render, but it's something that just focuses on our logic and doesn't really have any impact on what we see on the screen. So just because this is just for key generation, a nice little hack here is, I wouldn't call it a hack actually, or this is what for temporary variables. When we got rid of the use effect and use state here, we're going to actually bring in something called useRef. And the useRef we're going to use in here to set a little placeholder variable. So now we have a variable that we can actually update and change without actually having to, I suppose, re-render the whole component. So I'm going to get rid of the use effect, and where I'm sending the ID, so that is when we're adding a to-do, we're going to say down here, where add to-do is next to-do ID, and we can say plus plus. And now we can add things and our console warning goes away. So this is actually a nice little trick for optimization. Like it's very unlikely that you'll want to re-render your component every time you're updating the ID. So this is how you would manage that. Okay. So as you can see now, we have all of our logic for our to-do is in a separate place. But what this means is we can update this very easily now. So it might have taken a lot of work to get there, but now what happens if we want to send error messages or update state based on incorrect values or do more logical checks? We can add it in the action that we want to carry these things. So it's a lot more declarative. We now look down on our to-do list. We can see that we want to remove a to-do here. We want to mark it done here. And we want to update the label here. That's just so much more declarative. And I think once you have this as an option, you can obviously think about your data a little bit more, and you won't have to get into weird refactoring. And if you had set up this initially with the reducer, it would have been a lot easier. So let's do a quick review over the useReducer hook. So the useReducer is a hook for state management in React. It is recommended by the React team for when you have complex state logic that involves multiple subvalues, or when the next state depends on the previous one. The useReducer takes two arguments, which is the reducer function and the initial state. When we use the dispatcher, it calls the reducer with the current state and an action. I hope you found this helpful, and if you liked the video, make sure you like and subscribe, because next week we will be going on to context. So until next time, happy coding.